So the reason why this pattern in letter D wasn't arithmetic is because we weren't adding the same exact amount each time. Like from Monday to Tuesday, we added $100, but to get from Tuesday to Wednesday, we added $110. And then we added another random amount. So the idea was that every time we were adding a different actual dollar value. That's why it's not arithmetic. Something has to be adding the same exact dollar value every single time for it to be truly arithmetic. That's the definition of arithmetic that we've said since the beginning of this packet. So it's not arithmetic because we weren't adding the same dollar amount. Now, if it's not arithmetic, in letter F, it says, well, could it be geometric? And that's an interesting question because that's always the other possibility. If something is not arithmetic, maybe it's geometric instead. Geometric means it has a multiplier. And it is interesting to think we were technically doing some multiplication in our process, so maybe there's a multiplier. Could we have multiplied something times 1,000 to get 1,100, and that number multiplied something to get 1,210, and that multiplied something to get 1,331, and so on? Now, instinctively, I want to look back at my calculations and say, oh, well, I must have been multiplying by 0.10. Duh, of course, that must be my multiplier. That was what I was multiplying by. But 1,000 times 0.10 really isn't the next number. The multiplier can't be 0.10. That doesn't make any sense. So now I'm thinking, wait, does that mean it's not geometric? If it is geometric, and I'm not multiplying by 0.10, what the heck am I multiplying by? So it is worth it to think. And this is a great strategy if you're ever not sure what a multiplier is. Think logically. If I did this problem with whatever the multiplier was, 1,000 times something, whatever our multiplier was, definitely gave us 1,100 as an answer. So think about this logically. Think about this almost as if it's algebra. 1,000 times whatever our multiplier was definitely gave us 1,100 as our answer. So how could we figure out the multiplier, the part we don't know? Well, if we think about it like an equation, we can divide the 1,000 to isolate the part we don't know. And that means the multiplier that we don't know would be 1,100 divided by 1,000, which would be 1.1. So in theory, if we applied a little bit of algebra, it looks like our multiplier should be 1.1. Let's see if that's true. Let's see if this really is the multiplier that would work for every single number in the table. If I confirm, I'll do, just to make sure I have it, 1,000 times 1.1, yep, that's 1,100, times another 1.1, yep, that's 1,210, times another 1.1 is 1,331. This is all looking perfect so far. Times another 1.1, 1,464.1, that's what I had, times 1.1. It looks like I can just keep doing this because it's working. 1610.51 times another one. Oops, that's where I messed up. Darn. But either way, you can confer with your own notes and realize this is totally multiplying by 1.1 every single time. And since we have a consistent multiplier, it's always multiplying by 1.1 every single time, then we know we have a true geometric sequence. So even though I'm not necessarily going to explain or show anything in this box, hopefully you can tell we have confirmed that the multiplier is 1.1. And since we have a consistent multiplier, that means it is geometric. And it is geometric because the same multiplier worked for every single number in the table. So I can confirm that it is geometric. I'll underline that so I know. Yes, it is. Its multiplier is definitely 1.1. Make sure that that makes sense. Make sure that that idea makes sense, because the next thing that we need to do is to write an equation. And I want to make sure that we understand how to adapt what we were doing in the previous lesson so that we can write that equation. So if you need to pause and make sure that the idea of the multiplier makes sense, do that. Because in letter G, we need to write the equation. An equation for something that has a multiplier or a geometric sequence would be T of n equals the initial value, which I call I, times the multiplier that I call m, to the power of n. That's kind of the general structure for the equation that we need. So I'll sort of highlight this so we can see it. That's the equation structure that I want to use for this specific letter G. So let's think about this. T of n is always T of n. I don't need to change that. T of n equals initial. The initial value is what we started with. They said initially we started with $1,000. That's what I'll call my initial value because they told us that. Initial is always the zero term in the table as well. So that was also 1,000. We could think of it either way. So $1,000 for my initial times the multiplier, which we just found was 1.1 to the power of n. There's my equation. Now here's my challenge for you. The last question, question letter H, is going to ask you to use your equation. If you can't figure out how to use the equation, then watch the last video in this playlist and I'll walk you through. But if you think you've got it up to this point, you don't have to watch the last video. You can do letter H on your own using this equation. Just think logically and see if you can figure it out.